Hey everybody, so you are watching this if you are going to redo some of your waves quiz. So I have made a copy of the waves quiz and then I have changed some of the answers. So we're going to go through some examples and hopefully it's going to help you finish up what you missed on that quiz. So this first slide here, the question is what I wrote. This is different than what is on your quiz, but what do you mean by wave characteristics? So we talk a lot about like, what is the wave characteristic that has changed? What has stayed the same? What we mean are, I think that there's 4 or 5 of them. The first is our wavelength. So it's the distance from one crest to another crest. That is our wavelength. And I will label this here with a W for wavelength. The second thing that you can measure is our amplitude. So it's from the top of a wave down to the dotted line, and I'm taking the ruler with me on accident. Top of a wave, top of a crest, we'll get to that in a moment, down to the dotted line. So it's how tall your wave is. I'll put an A here. The third is going to be a trough. So that's the bottom of your wave. So here's our trough. We'll put a T for trough. And then the fourth is going to be your crest. So it's the top of a wave. So here is a top of the wave. I'll put a C for crest. There we go. C for crest, top of the wave. And then our fifth one that is a little bit less obvious is going to be oscillation. So what do we mean by when we say like a wave is oscillating? It means that it's going up and down over and over and over in a really repetitive pattern. So this arrow over here, this double-sided arrow is representing it going up and down and up and down and up and down for basically forever until we stop it. So I'll put an O for oscillation. So those are our wave characteristics that we can label on a wave, and hopefully that helps you answer that first slide if you missed some stuff on it. Go ahead and go to my next example here. So I have picked a different screenshot of a different wave than is on the quiz. So don't just copy what I'm writing. You should try and understand how I do it, and then you can go back to your quiz and fix it. So the first question here says, estimate the wavelength. So to estimate our wavelength, I said it was from one crest to another crest. I'm going to go ahead and draw a line from the top of one crest to the top of another crest. And how I'm going to do it, there's multiple ways to do it, but how I'm going to do it is I'm going to go ahead and count how many of these dashes on the ruler are between these two lines. So each one of those dashes is 0.2 of a centimeter, so we can count by them. So 0.2, 0.4, 0.6, 0.8, 1, so there's 1, 1.2, 1.4, 1.6, 1.8. Oh, 2, there we go, there's 2, 2.2, 2.4, 2.6, 2.8. So my wavelength here, the distance from one crest to another, is going to be 2.8 centimeters. All right, next one, estimate the frequency. This one's a little bit tricky because whenever we did Desmos labs, you had the ability to change the frequency down below. And here, like, there's no dial for frequency. I want you to try and figure it out. So frequency is basically number of waves. So how many waves are showing divided by time. So I'm going to go ahead and count how many waves I have here. And a wave is a complete up and down and back to that center. That is a complete wave. So I'm going to start at the very beginning. So up, down, back to the center. That's one wave. Up, down, back to the center. That's 2 waves. And then I've got this half of a wave, just at the upper part. So I've got 1, 2.5 waves. 0.5. And I'm just going to divide that by whatever my time says. So 1.06. 0.06. So that is going to be my frequency. And I'm just going to use a calculator. Divide by 1.06. I got 2.36 after I round it. So 2.36. All right, so next I'm going to measure my amplitude of this wave. Amplitude, as we said before, is from the center dotted line up to the top of a crest. So I'm going to go ahead and draw a line on my ruler over here to the left. And I'm going to count it the exact same way I counted wavelength. I'm just going to count the dashes because I know each dash is 0.2. So 0.2, 0.4, 0.6, 0.8, 1. So my amplitude is 1. 0.0. And then the very last thing that we have to calculate is our wave speed. So wave speed is how far our wave has gone divided by whatever our time says. So distance this time divided by time. And how I'm going to find distance is I'm just going to go ahead and look at this ruler in the background and see how far my wave made it down this line. So this is the end of my wave right here. And I know that this is 6 on the ruler, so I'm going to count 6.2, 6.4, 6.6, 6.8. That's how far it went, 0.8 centimeters. And I'm going to divide that by my time, so 1.06. And I'm just going to plug that into a calculator. 6.8 divided by 1.06. 6.41. So there we go. 6.41 is going to be my wave speed. Great. Okay, so I'm going to move on to a different sort of problem that's on the quiz. There's a couple of these where I've given you a graph and you have to estimate the wavelength, and then maybe talk about which wave characteristics is the same. So to estimate wavelength here, we're going to do the exact same thing we were doing on the previous example, except for now this time, because it's on this very nice graph, we could start at the origin of the graph. So we can start right here. So I just need to find one wave. So an up and a down and then back to a middle. That's my one wave. I just want to know how long that is. And if I look at this x-axis down here, it's 1 centimeter. The wave on the quiz is going to be different than this one because this is just an example. So make sure you double check what your x-axis says. So I type in 1 for here. And then the second question, which wave characteristic is the same for both of these waves? So our wave characteristics, we went over them at the beginning of this video. They are crest, trough, amplitude, wavelength. You can maybe talk about frequency. So if you look at this, you need to find something that is similar about these waves or that is the same about those waves and try to pick one of those wave characteristics that goes along with it. And if you look at the definitions for those wave characteristics, I'm confident that you'll be able to figure it out. All right, next sort of example problem. It says that, okay, so we have 2 different waves and a setting was changed in the simulation. There's 2 ways to change the simulation to get this. You just need to pick one of these waves. So what I would suggest to you for this one is go ahead and open up the PhET simulation. And you can just go ahead and press play and start messing around with these dials and see what you can change to make this wave look like the waves in this picture. And once you figure out what you changed to make these 2 waves, that's going to be your answer. All right. So for this one is like, it's the exact same slide as what is on the quiz. So I'm just going to give some hints. You've got this graph down here and it's your wave velocity versus frequency graph. And the question is how do the different A values affect the shape of the graph? And what I mean by this is you can look here, this blue line has one A value. The red line has another A value. Can you find any similarities between these A values and where these lines are on the graph? That is what I want you to write in this area. And then for the second question, it says, what do the A values tell you about the wave itself? You can go ahead and look at this equation. So what is your A value equal to? That's really going to help you on this one. All right, next slide. So slide 6. So this one, I've changed this number here from the quiz, so make sure you're not just using my numbers. And I'm going to erase these nice little drawings I made on the previous slide. So you've got this graph, and this graph now is wavelength versus frequency. And what I want you to do is use this graph to estimate the wavelength for both blue and red graphs when the frequency is 5.0. So you need to use these equations. So that equation and this equation for the blue line That one goes up here, and for the red line. And you're trying to find wavelengths, so you don't have to do any funny manipulation or fancy manipulation to this equation. You can just use the equation as it is. And your frequency is whatever the number is, -5 in this example. Yours will be different in the quiz, but you just need to plug that number in right here for frequency. And then solve. And then the second question here, it says, what could have caused groups A and B to have different A values from the experiment? This is directly from Patterns in a Wave Desmos lab. And if we look at our PhET simulator, you can go ahead and do something very similar to what you did on 2 slides ago. You can mess around with these dials and see what you can change down here that's going to affect our frequency. So if you keep frequency the same, what can you do to these other dials? And which one of these has an effect on frequency? That's going to be your answer. All right, and then last slide here that I'm going to go over as an example. So this says, craft a claim regarding the effect that changes in frequency have on wavelength. So basically, when we increase our frequency, what is happening to our wavelength? So I'm going to go to the PhET simulator, and I'm going to take it off slow motion, and I'm going to start frequency really low, and I'll make the amplitude a little bit bigger so we can see it. There we go, normal. So there's my wave. And if you can look at the wavelength, remember it's the distance from a crest to the crest. Right now I've got like a really long wavelength. It's a really long wave. So if I increase the frequency, what's happening to my wavelength? Are those waves getting closer? So is my wavelength getting smaller? Or are they getting farther apart, meaning that my wavelength is increasing? And then this last question here, I saw a lot of people missing this one. It says the characteristic of the graph that supports this claim. This is the graph that I want you to use. So we've got wavelength on the y-axis and frequency on the x-axis. So as we go to the right on the graph, we increase our frequency. What is happening to our wavelength? And how do you know based on these lines? So what are these lines doing that points you to the right answer? All right, so that is all I got. Good luck on fixing your quizzes. I hope everyone does well. Let me know if you have questions. Thanks, everybody.